Okay, well, so hello everyone. Today is a webinar for advanced modeling. So I am Bo. I'm the business developer for Asia Pacific market. So for the webinar Games of SWOOD, now this is a season 2. For the season 2, episode 1 is SWOOD Design Advanced Modeling. So today I will show you some advanced operation for the spatial modeling. Okay, well, the presentation of today, there are two different parts. The first part is how to create one curved and complex shape for the furniture. And the second part is how to create a furniture with some sheet metal part inside. Now let us to see how we can create this type of furniture. For the first part, curved and complex shape. So why here we propose you this mode to create some complex furniture. The advantage is it's a very flexible mode to create a complex furniture. You can just create one template, and anytime when you need to create some special curved furniture, you just need to use the template, modify the curve, and you can create easily the furniture. Of course, this way will help you to win the time, save a lot of time, and we can manage the curved multi-layer material, the curved panel, and we can manage the layout with a special curve. So now let us to see what is this mode. You can see here I have my global interior layout. So here I have one special furniture based on some free curve. And this curve is one B-spline. You can use drag and drop to move this curve. And here you can see I just extend the extremity and modify the position of this curve. When I validate this operation, you can see my furniture change the shape. The shape of the furniture follow the changement of the curve. To create this type of furniture is not difficult. You just need to introduce your template or your component, just modify the driven curve inside of the furniture. Give him some constraint for the point. Of course, don't forget to give him some tangent to get exactly the coincidence between the original curve and destination curve. For example, I can drag and drop to position it by some driven point. And here, when I validate this operation, you can see my furniture is coming, and here I get one curved furniture, and this shape have exactly the same orientation and same direction of my B-spline curve in assembly. So now let us to see how we can create this type of furniture. So to create this type of furniture, you need to create one special furniture template, or it's a special furniture component. So this component is saved in the furniture library, in the frame library exactly. And of course, to create this type of furniture, we will use Wetman part inside of assembly. We will manage some curved panel, and we will manage the orientation of brush material for the special shape. Okay, now let us to see some details, how we can deal with it. And here, let's start. So I will create just one assembly and save it in my frame library. I can give him any name. For example, here, just name it as curved furniture. Okay, my furniture is created inside of the library. And of course, for the first step, I need to create one driven curve. And this curve permits us to create the global shape of my furniture. And this one will be the driven curve is a driver to control all the global shape. I just save it. And now I begin to create the global construction by create some special curve. Of course, the element, the most important thing is all the calculation, all the curve, all the shape comes from the original shape. So here what I do is just create some offset for the first B-spline and I convert the original curve. Here I just get some offset curve. And now I begin to create the construction. So based on all these special curve, here I can directly create one plane. And this plane is calculated based on the existing curve and extremity point. So on this plane, I will easily create two rectangles. And of course, I can give some constraints and some dimension for the different rectangle. So you can see here, I just create two rectangle. I can give him some coincidence between different points. For the height, I will give him 520. And here, for this second height, I will give him 320. Okay, I just create the section of the furniture. Now let us begin to create some part inside. I will try to create the chassis for my furniture, the section chassis. So what I need to do is just create one part inside of my assembly, and here just give him the name chassis and convert the section rectangle to my Weidman part calculation sketch. And here, after I create it, I just need to go to Weidman tab and use the special section that I have inside of SolidWorks to create directly the chassis. So you can see here, with the Weidman component, I can easily create the global chassis just by clicking on some segment. And here the software can help me manage easily the meter card. It can help me manage the other connection, even the position of all the parts. Of course, just inside of one function, I can start a new group who permit me to create the second group of the chassis. And here, I get several different Weidman parts. Well, the design for the section is finished. So you can see here, this chassis section have different material. I can just use drag and drop the SWOOD material to apply the material on it. And after that, I can tell SWOOD panel definition that this one is a multi-body panel. So inside of this part, we have several different body, and each body inside of SWOOD, you can make the calculation easily for the orientation, define what is the top direction, what is the front direction, and here it will correctly recognize the good dimension for length, for width. Well, here, for the chassis, the work is done. After we did this work, and here, what we need to do is just make some repetition. I can easily use curve-driven pattern, tell the system, based on this curve, I will just repeat my chassis construction with the number 3. Of course, I need it to be tangent to my curve. When I click on my chassis, you can see here the curve-driven pattern, Sorry, just 1 minute. Excuse me. So I just oh yeah. Okay, just start too earlier. Yeah. Okay, sorry about it. I just start. Why? Yes. Yeah, I think I started a little earlier the presentation, and there are still some people didn't see the beginning of the presentation, and I will. So at the end of all the webinar, we will have the release of all the video of webinar, and in the video you can see the element you didn't get at the beginning. Okay, now let us continue. So because everything is created by the driven curve, and here we want to modify the driven curve, give him the different position. You can see because all the element is created by this driven curve, and here when you change the original driven curve, all the global shape will be changed. So here, the idea is you just need to modify the basic driven curve, and here, the calculation will be done. Now the work is done. Okay, so this is how to create the curved template, and this curved template permits you to directly get some special template, and each time when you want to use it, you just need to modify the original curve, and here the global shape is changed. It could be useful for the furniture, especially with the curved shape. You just need to create one template, and you needn't to create the special furniture each time. When you want to use it, you just need to introduce your component and modify the original curve, and here the work is done. Okay, now let us to see some details inside of the first creation. The first element, I used vitamin part inside of the assembly. So why I use the vitamin part? Because the vitamin part is very easy to create chassis construction. It permits you just to create the global chassis by clicking on the curve or on the sketch. And it's quite easy to modify the joint between two parts. You can easily create meter cut, you can create mine cut, you can create different connection between different parts. But be careful, this mode is just some multi-body parts. Multi-body parts have some limitation. Inside of SWOOD, we can manage easily one part list with all the dimension of each different part, but there are some special things. You can't apply the machining programs on each multi-part body. So if you want to get one machining programs for each part, you can convert this multi-body part into assembly. And after that, you can apply the programs to each part. So this is 2 points. You should be careful when you use development parts inside of this type of conception. Okay, now let us finish this creation. We just create the chassis. And now let us see how we can create the global construction of the furniture. So here, for the front plan, I can directly create one part on it. We will create some front board and back board. So we will use extrudation create some curved panel based on one line. So here it just converts this line inside of my part and directly create one extruded part. When I use extrudation, I can give him one extrudation direction, and of course, I can give him some thickness. And here, my curved part is created. Of course, anytime when you create your part, if you need to modify it, you can go back to the function to modify it, or you can just tell the system here, I can directly modify any face to attend the face, get some additional length. For example, here, just tell him I want 50 millimeter additional length to cover all my construction. And now the backboard is created. So exactly with the same way, I can create the front board, I can create the backboard. So the curved panel is created. And now you can apply the material on the curved panel. And here, when you want to modify your panel, you can see here, the curved panel, SWOOD can easily manage it by using some basic curve. When you give him the indication of the basic curve, and here, the curved panel will be unbound, and SWOOD will generate automatically the calculation of the unbound dimension. So for example, this front panel, I just tell the system this is my curved panel and the basic line is here, and it will directly unbound it, find the thickness, find the length, width of the panel. And of course, not only we can create this type of curved panel, even for the panel have the special shape, we can modify it easily. So here, just on the top line, I can directly convert some arc inside of my part, and after that, create some parallel line with extremity, directly get some special section. So here you can see, I can just give him some extremity, and here my closed curve is created. Well, when I give him the extrudation, I can tell him, I can give him some offset distance, give him some additional thickness, and here the part is created. Of course, anytime when I want to modify it, I can extend this panel, give him some additional length. Okay, the work is done. Here I have my global furniture. So be careful for this type of shape. Sometimes you need to give him some special information for the brute dimension, the brute material dimension. What does it mean? So here, for example, when I just use the default orientation, maybe the dimension of the brute material is not the minimum dimension. So here, I can give him some additional line and tell the panel function what should be the correct dimension for the length to calculate the brute dimension. And here you can see, after I give him some additional indication, my panel have the correct brute dimension for the length, width, and thickness. Okay, so this is everything that we need to do with this type of furniture for the chassis, for the banded panel, and for the curved panel, and for the panel with special shape. Now let us to see how we can directly use this type of component inside of assembly. Before we do this, we can make a small test. We can modify the driven curve inside of our furniture. You can see here, when I change the original driven curve, the global shape, the dimension of my furniture is changed. And here, I can control everything just by changing the first driven curve. For example, we just want to transfer it to some arc, and here we can see the work is done. Okay, well, now let us to see how we can use this one. To use this type of component, it's not very difficult. So we can just create one special curve inside of our assembly and directly introduce our component. And by giving some coincidence between the driven curve and the final destination special curve, we can change easily the shape of the furniture as what I want. So here, now let us to see the video. This is my global design, and here I just create some special curve on it. On the top line here, I just give him some simple point and create my first B-spline. Okay, and now the work is done. So of course I can repeat this operation several times, create several different segments. And why here I create several different segments? Because normally the panel have some limitation. I can't create one furniture with a big panel who have 5 meters length. So here I just create several different segments, and here I can introduce several different parts of my furniture. So the first furniture is coming. I just give him some good orientation and give him the original point. Well, now I just need to modify my curve just by dragging and drop the driving point here. I can directly give him the new position. Of course, I need to give him the constraint to give the good orientation of my driven curve. By using drag and drop, I can give him some positioning point. And here, after I validate this operation, you can see my furniture change the shape. And now I get exactly what I want, a curved furniture. Okay, so I just need to repeat second time the operation, I can get second furniture. So here the operation is exactly the same. I just use drag and drop, give him the position to the top plane, give him the indication about the original point. And after that, just modified the driven curve to give him the correct shape refer to the destination curve. Of course, don't forget to give him some orientation, otherwise maybe the orientation of the curve is not good. Okay, now get some coincidence between different points. Okay, now the work is finished. I get the second part of my furniture. Well, easily I just create different segment of my furniture. And of course, anytime when you want to modify the final shape of your furniture, you just need to use the driven point. You can use drag and drop, change the length, change the position, modify the extremity of your curve. After valid the modification, your furniture will change the global shape. Okay, so here what I need to do is just active the left side and the right side. And now the creation of my furniture is finished. Okay. Okay, now let us to see the other element. So now let us to see the second element of the presentation. So here, for the second x-axis, we will create one sheet metal project. What is this sheet metal project? So now let us to see some details. Here, this is my furniture. You can see my furniture not only used wood material, we used some sheet metal part too. This sheet metal part we can directly use inside of our project. So use sheet metal part in the project, we can make the sheet metal part parametric. So it means when I change the global dimension of my furniture, everything will be changed. And of course, we can calculate the unbound dimension for the sheet metal part. Okay, now let us to see what we can do. The first step, we will create some component inside of SWOOD box. Okay, we will create one SWOOD box component and with some sheet metal part inside. Of course, for the sheet metal part, we can create some band and unbound configuration to make the calculation of the sheet metal part. And after that, for the sheet metal part and some wood part, we can apply the SWOOD material to get the result inside of our report. Okay, now let us to see how we can do this work. At first, I will create one new SWOOD component. It's a metal door. And here, for this SWOOD component, we can directly create some sketch on it. So before I do this, I can move some offset plane. And on this plane, I can directly create one new part. So we will start the work just by creating one rectangle. This rectangle can get some constraint with the SWOOD box frame. So here, I will give him some coincidence with different edge of the frame. Now, if you change the dimension of your SWOOD box, and you will directly get the dimension of your part changed. Well, the second step, we will change directly this rectangle to some sheet metal part. We can easily extrude this one by giving some thickness. And here, with the sheet metal function, we can convert easily the sheet metal part. We can convert easily the body to sheet metal part. By clicking on the band edge, and here it will generate automatically the calculation of the sheet metal part. Of course, you can manage easily the extremity, give him the covering or the covered side, or give him the offset distance. And now the work is done. I get just one sheet metal part. Of course, with some advanced function inside of SolidWorks, you can easily create some flange. Okay, give him some additional flange and modify it as you want. Okay, now the work is done. So you can see with sheet metal function, when you create the global construction, SolidWorks will directly create the shape with some sheet metal character. So for this one, you can easily modify it. For example, you can tell the system, give him some additional configuration. Here, you can tell the system, calculate the n-band part. Automatically, you can create the n-band calculation. And now you have two different configurations. One default configuration and one n-band configuration. So refer to the report result you want to get. You can decide which one you want to use. And of course, anytime you are free to modify the sketch to directly create some additional handle, some flange. Well, we will not repeat the sheet metal function. So here, in my final assembly, I will just introduce some wood panel. With the function panel, I can create a new panel. Of course, I need to give him some margin to the four sides. And now I can directly put my panel inside of the chassis. So here I will just give him some distance. And now I get the correct dimension of my panel. I validate this one. And now I have my furniture door created. Of course, don't forget to apply the material on your part. And here, the work is done. Just use drag and drop and get the material for the part. Okay, so this is a creation of the component. Now let us to see how we can directly use this one inside of our furniture. This is one furniture with a lot of sheet metal construction. I can just use drag and drop to introduce SWOOD box inside. Give him some reference plane to get the correct position. And here, my metal door is coming. I get this construction. Of course, I can repeat several times the same operation to directly get the inside volume. Of course, I can give him the special indication for the different plane. And I can even modify the orientation after include this SWOOD box. For example, I get the handle here. I just need to make the rotation on it. And here, my part will change the orientation. Well, now let us do the last work. I will just introduce the last door. Not only we can use some plane to make the special position. And of course, here, I can click on some existing surface of the chassis to directly position it. And when I validate this operation, of course, I can always change the orientation. Okay, and here, the construction of my furniture is created. So, because everything is created inside of SWOOD, so here you can easily modify the different dimension. When you change dimension, well, the global dimension of the furniture will be changed and each element will be changed. So this is a way to use a parametric sheet metal part inside of SWOOD to create some parametric furniture with the sheet metal part inside. Okay. Well, so this is all the elements that we need to present today for this webinar.